In this unit, we've been talking about finding derivatives of functions and their inverses. So in this section, this lesson, we're going to talk about the derivative of inverse trig functions. So first of all, let's just do some review. We'll bring back some things that hopefully you've seen before and that you remember. If not, I'll just try to get you there. So we've got this graph y equals sine x, and y equals sine x is a function. However, if we were to try and graph the inverse of that graph, that would no longer be a function. So in order to have the conversation about the inverse of a trigonometric function, mathematicians have agreed to restrict the domain of the sine graph and cosine graph of any trig graph so that we can have the discussion about its inverse as a function. So for example, sine of x, in order to get one complete cycle, mathematicians restrict the domain of the sine graph between negative pi over 2 and positive pi over 2. And then we use that information to then graph or discuss its inverse. We'll talk more about the inverse in just a moment. So if I look at this unit circle I have on the side here, negative pi over 2 is here, positive pi over 2 is here, and every value that is between negative pi over 2, positive pi over 2, that's where inverse sine lives. So that's where we'll find the answers to our questions. I'll explain a little more in just a moment. Okay, so that's where sine is between negative pi over 2, positive pi over 2. Let me start labeling this. So this is sine x. Cosine, the agreement is to restrict cosine between 0 and pi. So for cosine then, 0 and pi. And tangent is the same as sine because tangent is negative, or is sine over cosine. So let me get a different color. Tangent is also from negative pi over 2 to positive pi over 2. So let's use some of this so I can explain what it is we're using this for. For example, if I said to show the inverse, so if we say that y equals sine x is the function, then we say y equals arc sine x is the inverse. You may have seen it written like this before as well. The problem with that is that there's some confusion sometimes, that students believe that sine negative 1x, because you see a negative exponent, is the same thing as 1 over sine x, when in fact they are not equal to each other. Not equal. Let's talk about what it does equal though. So whenever you see inverse sine x like this, or arc sine x, those mean the same thing. Let's talk about what they actually mean. You've probably seen this before, you've used it before to find the measure of an angle. And that's exactly what arcsine is saying, is what is the angle measure that gives you this ratio, this sine ratio. So for example, if I say that we have y equals the arc sine of x, the inverse of this is saying there is the sine of this angle y that will equal x. So what we're solving for is, what is the angle? That's what we're looking for. In this situation, the original function, we know the angle. And we're trying to find the ratio, the opposite over hypotenuse. Well, in our case, we're saying what is the angle if we know the ratio? Let's do a couple straightforward examples and then we'll get a little bit more complicated. So for example, if I asked you, what is the arc sine of root 2 over 2? So keeping in mind that we are restricting our values here because we're looking at sine, we're restricting our values to between negative pi over 2 and positive pi over 2. So what this question is actually asking you is the sine of some angle theta, you can use x, y, theta, is going to be square root of 2 over 2. And we know, because we've restricted the domain, that theta has to be somewhere between negative pi over 2 and positive pi over 2. Okay, because you know the unit circle so well, you know that the solution to this problem, theta equals pi over 4. The sine of pi over 4 is root 2 over 2. So the arc sine of root 2 over 2 is pi over 4. Okay, not bad. It's just inverses. We're finding the angle measure instead of the ratio this time. Let me give you another example. Let's do a tangent example. So let me number this as number 1. Let's do an example with tangent. I would like you to pause this, please, and find the arctangent of -1. Please pause this and go give it a try. Think about your unit circle. Okay, welcome back. So this is saying the tangent of some angle on the unit circle is going to equal -1. Well, since tangent is negative, I know that I'm down here in the third quadrant. So I'm down here somewhere. And since tangent is equal to -1, that means sine and cosine must be equal. So that's this angle right here, because both sine and cosine are root 2 over 2. The difference here is that we're at -1, and keep in mind what the domain is. The domain restriction for this angle is between negative pi over 2 and positive pi over 2. So in this case, our angle is negative pi over 4. So the arc tangent of -1 is negative pi over 4. You may also know this as 7 pi over 4. Those are in the same location on the unit circle. However, 7 pi over 4 is not within the domain. So you need to really be careful that you're sticking with the domain that has been agreed upon by mathematicians throughout time, and make sure your answer stays within. Okay, so that's generally arc, sine, arc, tangent. Let's see if we can combine some things together here. I'm going to use a different color. So for this third one, I would like you to find the sine of the arc cosine of negative root 3 over 2. So think about order of operations. You're going to do what's inside of the parentheses first. So you'll find the arc cosine of negative root 3 over 2, and then you'll take the sine of that. Go give it a try. Okay, welcome back. Remember, the domain restriction for cosine is everything between 0 and pi. So what we're looking for this middle part, I'm just going to do the middle part first. We're saying the cosine of some angle is negative root 3 over 2. Okay, knowing your unit circle, I know that that's going to be the cosine, so it's going to be a 30-degree angle. I know that I'm going to be in the second quadrant, so I'm over here. And a 30-degree angle is pi over 6, so this will be 5 pi over 6. That 5 pi over 6 is within the domain, so the arc cosine of negative root 3 over 2 is 5 pi over 6. So replacing this inner part that we just calculated then, now the next part of the question is, what is the sine of 5 pi over 6? Well, if we know that cosine is root 3 over 2, sine is going to be 1/2. And since we're in the second quadrant, sine will equal positive 1/2. Now it's okay that we're in the second quadrant because we're looking for sine, not arc sine. So it's okay when we're still within the domain that is required for a sine function. Okay, one more of these and then we're going to get into something a little bit more fun. I'm thinking green this time. Please find the, let's say the secant of arc sine of 1/2. Go take a minute. I want you to actually try. Okay, welcome back. So first of all, we'll do the part that's on the inside. Arc sine, we know the domain restriction is between negative pi over 2 and positive pi over 2. Sine is 1/2 at a 30-degree angle, so I know that that angle will be pi over 6. So now what I'm looking for is the secant of pi over 6. I know that secant is equivalent to 1 divided by the cosine of pi over 6. So now this is where we make the reciprocal. Not if it says sine to the negative 1, but if it says secant, that is equivalent to 1 divided by the cosine of pi over 6. We knew that sine was 1/2 at pi over 6, so we know that cosine is root 3 over 2. It's probably not best to leave a fraction within a fraction, so I'll do 1 multiplied by the reciprocal of this, or 2 over root 3. No need to change that denominator. You can leave the radical right there. So there's our solution. Okay, let's get away from the unit circle values a little bit and start looking at this a little bit more algebraically, if you will. So what we're going to do next is look at something that's a little bit more theoretical. So if I were going to say, find the cosine of the arc sine of x over 2. Well, x over 2 is not a ratio that's on the unit circle that we know. But what I still know some things. I still know that the sine of some angle is going to be x over 2. So that's the first thing I know. The second thing I know is that sine is opposite over hypotenuse. And I know that sine is a ratio from a right triangle. So if I draw in a right triangle, because that's where sine comes from, is the opposite and hypotenuse of a right triangle. I always draw my right triangles this way. You can do whatever you want. I always put my angle there in the bottom left. And I know from that angle, the opposite side is x. The hypotenuse is 2. Well, the question is asking, what is the cosine of this angle? Like, what is the cosine of this triangle that has the opposite side of x and the hypotenuse of 2? Well, I know that cosine is adjacent over hypotenuse, so I get to do a little bit of work here to find this adjacent side. Since this is a right triangle, I can use the Pythagorean theorem. 2 squared equals a squared plus x squared. A squared equals 4 minus x squared. Therefore, a is the square root of 4 minus x squared. I cannot take the square root of each of those terms separately because of that subtraction sign in the middle. So we get to leave this side as the square root of 4 minus x squared. We don't get to change that. Now, let's finally answer this question. What is the cosine of a triangle where the sine is x over 2, is what this is asking. Well, cosine is adjacent over hypotenuse. Adjacent is the square root of 4 minus x squared. The hypotenuse is 2, and that is the solution to our problem. This is all theoretical. This is saying what is the relationship between these. We don't have an actual value that we can calculate, but we're saying if we knew what x was, this is what the cosine would be. I'm going to give you another one to try on your own this time. I'm going to stick with hot pink because it feels inspirational. I would like you to please calculate this one. Tangent of arc cosine. Let's do 3 over x this time. Take a moment, see if you can calculate, or not calculate, see if you can evaluate this expression. Okay, welcome back. I'm going to do the part on the inside first. I know that the cosine of some angle will be 3 over x. And I know that this is adjacent over hypotenuse. So I'm going to draw my right triangle. And I know that this adjacent side is 3, the hypotenuse is x. Using the Pythagorean theorem, I know that this opposite side is x squared minus 9. So in order to find the tangent of that angle, where cosine is 3 over x, I'm going to use the opposite side and the adjacent side. The opposite side, x squared minus 9. The adjacent side is 3. Okay, I'm going to do one more, and this one's going to incorporate a couple of things. These are some common misconceptions. So this will be the very last one that we'll do. I'm going to do a dark purple. I would like you to please find secant squared of arc tangent 3x. I would like you to take a moment and give it your best shot. And when we come back, I'll show you some areas to watch out for. Okay, welcome back. I'm going to take a little more space on this one because I want to make sure you've gotten all of the I's dotted and the T's crossed. So the inside of this says that tangent of theta is equal to 3x. I know that tangent is opposite over adjacent, so I'm going to make this into a fraction, so I can say this is the opposite and 1 is the adjacent. Okay, I'm going to take up a little bit more space on my right triangle here. Because I'm going to have a little bit more work to do. The opposite side is 3x. The adjacent side is 1. Now, if we use the Pythagorean theorem here, you need to really be careful because the Pythagorean theorem says we are squaring the entire quantity of 3x plus we're squaring the quantity of 1, and that equals, I'm just going to use h for the hypotenuse squared. So if I square that 3x side, I'm going to get 9x squared plus 1. Make sure you're squaring both the 3 and the x. And then the hypotenuse will be the square root of this. And I cannot take the square root of each one separately. That addition kind of throws a wrench in the works. So I've got 9x squared plus 1. All right, the question is saying now, what is secant squared of that angle? Or because what we just talked about before, we know that's also the same as saying 1 divided by the cosine squared of that angle. And an even different way of thinking about that is 1 divided by, find the cosine of that, and then square it. So let's find the cosine of this triangle. The cosine is adjacent over hypotenuse. So we've got 1 over adjacent over hypotenuse. And then we'll square that. So I'm going to square the numerator and the denominator. When I do that, 1 squared is 1. The square root of 9x squared plus 1 squared is just 9x squared plus 1. Now I can't just leave this as a fraction. I can write this because it's 1 divided by that fraction, so I can multiply 1 times the reciprocal. So it's just 9x squared plus 1. All right, I think we've done enough examples here that will give you enough opportunity to try these tonight on your homework. So good luck, and we'll talk about it more next time.